Good morning. Just managed to get it in, so I've got a minute or two left to say good morning. So I'm talking about implementing intelligent data management. And what do we mean by this? Well, basically creating a coherent data management platform, active archive, flexible workflow, compliancy, and access from anywhere, anytime, anyhow, and availability. So those are the core elements we think can maintain this. When I think of intelligent data management, I actually think this is an electronic version of my wife. I'd better hurry and explain that before your imagination runs riot. But I think like a lot of people, especially men, I have to say, my idea of taking care of data is when something comes, I have a very good system. If it's really important, I put it on the left-hand side of my desk. If it's very, very important, I put it on the right-hand side of my desk. And basically, 2 months later, it's gone in the bin. Which means that when I lose something and I ring up the insurance company and say, this has been stolen, can I have money for it? They say, yeah, sure, give me your proof of purchase. In which case I then spend 5 weeks trying to find it and failing miserably. Whereas my wife will get up, go to her filing cabinet, find the right file, all cleverly indexed and labelled, find the right piece of paper, scan it, fax it off, and in 10 minutes it's done. So when I think about intelligent data management, I just think of my wife and she does it properly. Now, I'm not suggesting that everybody in data management is disorganised, but I think there might be a little element of that. But there's also the issue of the growth of data, especially unstructured data. So when I'm talking about intelligent data management, I'm primarily talking about unstructured, to some degree semi-structured. And I think the growth in the activity in the marketplace at the moment, business has been driven, and there's a huge amount of growth of data, plus the fact that it's difficult to manage all this, and sometimes perhaps when we have to do it manually, we just don't take the right amount of care, leads to a lot of problems. So just to give a brief intro, I'm not going to talk about Eurotech specifically, but just to say why we qualified to talk about this. We're not a vendor, we don't sell software, we don't create software rather, we do sell it. We were founded by upstream oil and gas people for upstream oil and gas people. So 20 years ago we were founded to address oil and gas issues in terms of helping people. And we do various stuff, we work with everybody, etc. But I think the last line is most important. We understand the IM world, we know what applications are. For example, we take Petroleum, we know what it is, we know how to tune it, we know what has to be done with it. And more importantly, we know how to take IT and apply it to that world. So we know how to make technology work for people like yourselves in the industry. So coherent data management, what's the issues with that as we see it? And this is based on some of our people, because they are geophysicists, they are trained, that's what they do for a living, and also our clients, because they're doing the same jobs as you do. So some of the issues we see, multiple data sources, or no tracking and management of data, often stored at multiple locations, and I mean globally. No security, unreliable storage mediums, multiple different types of tape, some of it perhaps old, that hasn't been transcribed recently, the usual sort of things. Different data types, no compliancy with regulatory controls. We're starting to see more regulation in the industry now, but it's slow in coming compared to some other industries. No internal compliancy, or which I mean forced upon you in terms of your data retained, when your license expires, is it deleted properly, the usual sort of things. Visibly limited to a small number in terms of who can access the data and where from. And no integration with other business areas. When we talk to people, the wish list typically contains these sort of things. So, automatic ingestion of data, policy-driven, so no having to say, right, I now need to sit down and specifically get this data ingested. It's done automatically once it hits the system. Give it a duplicate data, by which I mean single instancing, so no multiple copies of the same data. Automatic movement of data, information lifecycle management. Long-term archiving, whether that's disk, tape, cloud, or the future may bring. Global multi-site coverage, I mean all of the organisations here today have multi-sites distributed across the globe. And there's always that old issue of where the data is, which country is it in? Is it in Stavanger? Is it in Aberdeen? Is it in London? Or is it in Asia somewhere? And we have a coherent platform that manages all of that. And obviously compliance and security, and things like automatic deletion. So if you've got data that has to be deleted on a certain date because the license has run out, does it get deleted? Or does somebody think, oh no, I'll keep that might come in useful. And then of course you get fined. And most importantly of all, perhaps the fact you can easily retrieve that data. So you may have it retained, stored safely for 20, 30 years, can you actually retrieve it when you want it? Minor details are quite important, obviously. So a solution typically is something that will sit in the middle and help all that. From our point of view, we have something called GridBank. It's a third-party ISV solution, it's software, and we've looked at it and thought how that would apply to oil and gas, because that's what we do. So how do we take this piece of software that does a lot of clever things to make it apply to data management and the information management world of oil and gas? And typically it'll sit in the middle of the environment, automatically ingest the data, index all the metadata, the contents, store it safely, wherever, and for however long you want, all done automatically by policy. Obviously there's some work involved in setting up those policies in the first place, but once you've done that, then from that point on, your data is automatically managed for you. And primarily, like I said, we're talking about unstructured data, but also data emanating out of applications. There's also the issue about project data and how you archive that and retain that as well. And that's another issue, but which we can also, which we're also working on in terms of a fully integrated solution. So what do we mean by coherent data management platform? One of the main bastions of what we're talking about. So it has to be policy-driven, ingestion of semi-structured, unstructured data, and basically it's generating a proper ILM without having to worry about the hardware. This solution is very much driven around the software and the actual point of what it does, rather than worrying about complicated, expensive, difficult hardware, etc. Information lifecycle management for G&G, so archival, retention, control shredding of data, encryption, e-search, audit, all the things you require as part of that. And not forgetting at the end of it that the total cost of ownership has to be sensible as well. It's all very well having a solution that does everything. If it's going to cost 8 figures, then it's not going to fly. Active archive becoming increasingly important in this industry, in this particular environment. So migrate, manage, share data in a secure repository, give you instant access to archive data. And when we talk about instant access, we mean instant access. So it's not a case of waiting for a tape to be retrieved out of a warehouse somewhere and brought on a van. And also we're talking about making this digital asset management, so it's all digital. So it may be stored on a tape, you may have to wait a few minutes, but when you want it, you will get it. Flexible automated policies to provide integrity, media monitoring, self-healing, versioning, and automatic ILM, all the things you'd expect from an active archive. Flexible workflow, so transparent data access, whatever the data is, whether it's a SegY file, a SegD file, whether it's a list file, or whether it's maybe Word files or GIS information, it doesn't matter. You've got access to that information, whatever it happens to be. And actually recognises over 500 different file formats within this solution. Centralised access to distributed data. The data may be distributed across multiple sites, including geographically dispersed, but obviously all your users need to be able to access that data, though through a secure environment, obviously. Interaction with the GIS environment. Removal of physical management layers, so you have one simple management interface to manage all this. Easy internal and external data distribution, whether it's internally or distributing that data externally, and I don't just mean out of company, but I mean across geographic sites as well. And also you've been able to archive and obviously in the future retrieve the information that you're working on, so whether that's pre-stack, post-stack, original field data, seismic data, well data, or whatever. All this has to be put to the archive. And obviously there are a lot of solutions out there that do archiving, but presented with a SegY file, it's not going to have a clue what to do with that. Obviously this solution does, because it knows what SegY is. Compliance and security, like I said, becoming increasingly important in the industry now. So it forbids unauthorized access, so if you haven't got access to that data, you can't get it, you can't retrieve it. Full audit trails, so when you want to do an audit trail, whether it's for compliance reasons, internal, external, you can do that. Track all changes of versions, obviously, you need to be able to do that. No accidental deletion, you can only delete a file if you've got authority to, or if it's at the end of the appropriate period. And when a file gets deleted, you can do full shredding, so that means it's gone completely. And that's under full Department of Defense US standards. Encryption, and if you use encryption, you want standard algorithms like AES, 256, Blowfish, whatever those mean, I haven't a clue. You can actually use any of those if you want to, depending on what your particular requirement is. And Worm as well, if you need Worm and want to implement Worm, then you can do so. Access anywhere is becoming increasingly important. If you want to access that data, you can. I don't just mean sitting at your desk in your office. If you want to access it from another office, fine. If you want to access it from your laptop out in the field, fine. If you want to access it from your iPhone, if you want to access 10 terabytes of SegD on your iPhone, it's going to be interesting, but to give you that flexibility to access data from anywhere. Secure role-based access to make sure that only you are accessing your data or anybody you authorise to access your data. Open interface, so protocols include CIFS, NFS, WebDAV, HTTP, so there's nothing complicated about this in terms of the solution. It just presents itself as a normal CIFS, NFS, or whatever file share. And perhaps more importantly, when you want to retrieve your data, you can do it by simple Google search strings, so you don't have to remember a particular name. So if you've accessed off a field that you've been working on, right, not doing anything with this, it's too expensive, put it away for 4 years. When you come to look at that again in 4 years' time, if you can't remember the actual specific project name, or you can't remember the name that you archived it under, you can do a string on the contents. And it'll come back and give you everything that you're authorised to look at, nobody else is, and you can then pick from that in terms of what you want. So you don't have to remember file names or use stubs like some other solutions do. And it's also a cloud-based architecture, and more about that in a moment. In terms of availability, simplified data migration, it has application awareness. It's in provisioning, grid architecture, so there's no single point of failure in terms of how this solution is actually architected. It uses a grid-like distributed file system for security, performance, and reliability. and built-in real-time application to a remote site. So obviously you've got all this data stored somewhere. It's secure because it is distributed across multiple servers. But there's also there's always the problem that a plane may land on the site, in which case your data's gone. So you can also replicate it remotely to another site, and that's all automatically built within the solution if you want to use that. I'm not going to talk about the architecture because you haven't got time. If you're interested, come and see us, or we can go through it. But perhaps the important bit is, at the back end, whatever you want to store it on, you can do. If you've got expensive disk and you want to use that for it, fine. We're not going to argue with you. If you want to implement 2 petabytes to put all this on, then don't use expensive hardware. It's just not worth it for this. At the end of the day, it's only long-term retention, so use cheap disk. It's cloud-enabled, so you can plug it into the cloud, whether that's one of our cloud partners or whether that's an S3. If you want to do that, that's fine. It's already enabled. Or obviously onto tape. The solution is disk and cloud-enabled, but obviously in this industry we know that tape's still very important. So we use LTFS, the Tape File System, in the back end to interact with tape libraries, whatever you may have. And a little bit more about that in a moment. Gridbank and IBM. IBM recognised the validity of this solution in terms of independently of us. They've taken it off, tested it, validated it, and it's now in their global catalogue. In fact, it's one of, I believe, only 40 ISVs appear in their global catalogue, with other small software companies like Microsoft and so on. So it's been tested across all their range, it's in there, so it gives us a tick of approval. And what we do find is that a lot of the clients we talk to are actually quite interested in this as an appliance, in the sense that if they've got infrastructure that can be reused, great, because that saves money, just buy the software, reuse your hardware. But there's always that issue, and I'm sure none of the companies in here have it, between IT and information management, where IT have a slightly different view of perhaps of what should be implemented compared to what you'd actually like. And we find that putting it as an appliance gives you the information or the data manager what you want, and it's protected. So IT isn't going to come along and take your storage and reuse it for something else. Somebody in HR has got a really important collaboration project that they want 10 terabytes for, and suddenly all your archive data has disappeared. So with IBM, we built and delivered this as an appliance, self-contained, fully reliable, fully supported, and from an information management point of view, it's there. Set up their policies, the data is ingested, archived, and they can access it whenever they want. So in summary, what we're talking about basically is ILM that fits G&G. So we're not taking a standard archiving or HSM solution or ILM solution and saying, yeah, this fits oil and gas. It's a bit rough and ropey, but yes, it will work. We've actually thought about this because of where we fit into the market and applied it to this industry. It manages all data, seismic and general unstructured data, semi-structured data, including email as well. So for example, you can plug your Exchange email into this, it will quite happily take that as well. Reduce storage and operational costs, secure long-term retention, gives you an active archive environment, and also guarantees compliancy. I think perhaps the important thing is it says at the end this is an IM solution, not an IT solution. So yeah, it's technology, but it's a solution for what we know data managers and information managers want. It's not an IT solution that we say, here, this is what you've got to use. However, the real world always bites. It is a strategic solution, but we do realise that sometimes we have to do these things step by step. I mean, we'd be quite happy if we were saying, yeah, I've got 5 petabytes of data, give me a solution to archive it. We'll be around on your doorstep straight away, don't worry. However, we realise it's not always that easy. You may have 5 or 10 terabytes you want to do straight away. We also know that we see people in data management we talk to, we show this, we demo it, they love it, they want it, they talk to IT, and IT will say, nah, it's all right, I'll buy an extra array of disks, you'll be fine, don't worry about it, you've got more storage. And we also realise that tape remains important to the industry as well. A lot of people we talk to would love to have all their long-term data stored on disk so that it is instantly accessible, but there is a cost implication in that. So tape is going to be around quite a while as well, so we know that this has to implement and interact with tape. So a reminder about Eurotech and leading on to the next step. We do understand what we're talking about. Like I said, we don't just supply technology, we supply services as well. So, for example, we've got people onto sites in some big companies and small companies doing things like application management, archiving, data loading, etc. So we know what happens on the coal face. We're not just an IT vendor trying to say this is IT, this is what you should do with it. And we also understand the enterprise space and the technical space within oil and gas in terms of what technology is used for. So we know, how to, like I said earlier, how to apply technology to this environment in terms of making it work for you. So therefore, you can actually use a phased approach. So if you've got a small project, you've got a few terabytes of data that you really like to have more control of and to be secure at the moment, there is something called the Tape File System. This was actually originally developed by IBM. The base product is actually free, but obviously you have to build something around that. From our point of view, it's an easy step in today. You can have a small single tape drive or library, archive your data, and it's secure, easily accessible. Basically, LTFS just allows you to use an LTO tape like a file system in terms of dragging and dropping files. However, you can put this in, use it today, and then you can scale up to use GridBank later. So there's no reason why you can't put this in, get your data saved, and then start looking at GridBank as a more strategic solution later in terms of then staging stuff onto that. And then LTFS just becomes the tape back end to GridBank. So I'm now going to hand over to my colleague to do that last taboo of doing a live demo.
Hi there, my name is Gareth Neville. I'm a pre-sales consultant for Eurotech. I just wanted to spend a few minutes to do a demo on LTFS. Basically, it's an easy to format, easy to access file system on a tape. There's two versions, the single drive edition and the library edition. The single drive allows you to access all data on a tape on a single drive as if it were a USB disk. The library edition adds support for multiple tape cartridges in a tape library and automatically loads a cartridge per file access. There's currently 3 tape generations available. There's the LTO5, the LTO6 and the TS1140. And you can see the native capacities and throughput. One of the things that I like about LTFS is that I think it combats some of the pain points that previous tape software technologies have given us. In the main, the backup software, archive software is proprietary. By that I mean basically they use their own formats to write the data to tape, they use their own indexing for the cartridges and the data that's on the cartridges. And in the case of operating systems, there are utilities that you can use to save data, but it's not so easy to find out what's on the tape at the time. In most cases you might have to restore the whole of the tape image before you know what's on there, especially if you haven't labelled it very well. So the way that I think LTFS actually combats some of these issues is that it's not really proprietary software. It's a simple download and install of a driver, and in the single drive edition it's actually a free download. It's a simple drag and drop method to copy to tape. There's no clever commands that you need to use. And it loads like a USB drive, so you can see your data straight away in a normal folder icon structure. And then in that case it's easy to actually select the files and drag and drop back off to the desktop. So for the demo, basically I've got 2 environments. I have a Linux environment and a Windows environment. I've got an IBM X3550 on the Linux side, PowerEdge 2950 on the Windows side. And what I've had to do here is just present the TS3200 library through a fibre switch so I can present it to both environments. But it's basically set up as 2 separate drives. So if I start the demo now, first of all I'll go to my Linux desktop. I've got here on the left, I've got this LTFS operations folder. And basically these are launcher icons which allow me to just double click instead of typing out long-winded commands in the command window. I've got my demo files folder, and then on the command window here. So first of all, I just want to type mount, and you'll see there, my window's very small so I can't see all the details, but there's an LTFS entry there which just basically tells you that the device is mounted to a file system. Hang on a second. I can't actually see it. I've got some folders at the bottom here that are actually off the screen and I can't actually select them at the moment. But what I'll do is, I think at this point, what I'll do is I'll probably run a video because it's going to be difficult to actually show that live now. If I just go to that very quickly. What I was going to do from that point is actually select a seismic interpretation tool and then do a basic install of it's exporting seismic data from this tool to a folder on the desktop. So if I show that now, and I'll try and narrate it as it happened. So there's a seismic information, got a well there, and I'm going to now just select and export the seismic 3D. You see it there, it's just selected through there, through to the 3D, and I'm just going to leave the defaults in this window, and I'm just going to give it a name that's something meaningful to me, and then I'm going to export that 3D data to a folder on the desktop. Okay. And it's successfully exported the data. And just minimise that. And now if I just open the demos folder, you can see the file there, LTFS demo, and it's been saved. That folder there, and then I open a link which is just a folder link to the LTFS tape drive, drag and drop, and in a few seconds you'll see it start to copy. It is tape, so it takes a little bit of time to actually get to the start of the tape. So from there, that's from the Linux side, I can then go to the Windows desktop. I just need to unmount the tape drive first. Just check that it's actually gone. And now if I go to my Windows desktop, I just need to explain here, there's a service that runs in the background on Windows, which is an auto mount for LTFS. And basically what it does is it polls the tape drives, and if it finds a tape, it automatically mounts it. Now I've had to stop that for the purpose of this demo, so it doesn't conflict with the Linux side. So I'm just going to run that up at this point. And then once that's run, I can go to my computer. In a few seconds, what you'll see is, you'll see that the tapes will be polling. You've got two icons there at the moment that are just dormant drives. And then, as you can see, hopefully, you can see that there's an egg timer on there, and that tape is now polling. And obviously, my computer's refreshing. And once that's mounted, the icon will change, just to show you you've actually got a mounted tape drive in there. There we go. And that's the tape that I've just taken from the Linux side, and it's now on the Windows side. And there's my demo files folder, and my file that I just saved, exported. And what I'll do is I'll drag and drop that over to the Windows desktop. And from there, on the desktop, I've just got a seismic viewer that I'll use to open. Takes a bit of time to come up. And then from that window, I'll now open the 3D that I've just exported from the Linux side. Go through, view all, and then there's my file again. Open it up in Seismic Viewer, and there you go. So that's basically showing how, using LTFS, I've been able to port the files from one environment to the other using simple drag and drop methods, and it's actually on tape format. I think it definitely gets rid of some of the pain points that we've had with tapes in the past. Certainly if you've got a lot of archive tapes, we do transcription, we get tapes over, and in some cases we get people saying, can you have a look at this tape? We don't know what the data is. Can you just find out for us? With the LTFS, the index of all the files is on the tape. You just open the icon, it's all available in front of you. And I think it's just one of those things that it's a simple and effective thing, but it does definitely help us. I also think going forward, going with the information management software that we've seen earlier from Tony, and a lot of the archiving systems, I think LTFS will go on the back of that as a third tier storage, and just a cheap option for archiving data. But the thing is, if you ever want to retrieve that data, it's very quick to get it back. Thank you very much. That's it.
I think maybe what it's a good idea to end with is how some of this has actually been used, or to put it into perspective. It's all very well talking about solutions and what they can do for you. So, for example, one company we've just put this into are using it effectively for data classification. So, in their case, they're only talking about 10, 20 terabytes of data in their head office. So, for them, it gives them a tool that they can classify all this data that's lying on USB drives in cupboards and on tapes in cupboards and on servers around the building. So they can classify it all, ingest it all, get it online, and then they can then retrieve it. The next step being then to move to implementing it to other offices, and ultimately bring it all together as one shared single copy of the data. Somebody else we're talking to, for example, has, in their estimate, around about 3 petabytes of seismic data. The majority of it stored on tapes in iron mountain holes in the ground somewhere. From their point of view, they think a petabyte of that they would actually like to have available at any time. So in their case, they're looking at they could use this to get that 1 petabyte of data up onto disk storage, make it available, and use this to actually ingest it and be able to give it retrieval. The other 2-3 petabytes they'll probably never touch again, but they need to know it's in a hole somewhere. Other companies we talk to see it a different way in terms of it's around data management. It gives somebody else we're talking to, a services company, looking at how they can use this as a data management platform. It's not so much in their case data retention and archiving. It's a way of saying that we're replacing some storage, so rather than just buy disk storage, perhaps we buy some cheap disk, use this as a way of managing our data. So that yes, we can use the compliancy and data retention, but in their case, the critical factor is that they can use this to actually do a proper data management platform, so they know where the data is. And like I said, if you look in most environments, anybody's using applications, OpenWorks, Petroleum, most of the others, etc. There is a good core tools around that allows you to manage and protect your data properly. But underneath this, and around this, and on top of this, is this mass of unstructured data that people are just really struggling with. And like I said, that can be things like SegY, SegD, etc. But it can also be the massive general crap that we all have in our environments, and also the GIS data and the other stuff that's growing rapidly. So it's a way of bringing all that together into a controlled environment. So like I said, it's looking upon this as more than just an archiving tool. It's actually becoming a proper data management platform for all that mass of unstructured data that's causing problems for everybody. Like I said, if you want to know more about this and see it, then just come to our table at the end there, and we can happily talk to you about what it really does and go into some more detail. So obviously we haven't got time to do that here, and obviously we wouldn't want to bore half of you, Richard, with it anyway. So thank you.
Do you have any questions? Yeah, this is more of a comment rather than a question. In the interest of full disclosure, I work for a tape line manufacturer. But the LTFS technology was developed by IBM, but it's an open format, so you don't have to have an IBM tape library to utilize LTFS technology.
Sorry, I was going to say that's certainly the case for the single drive edition. That's a free download, as I said. But at the moment, the library edition is firmware and license from IBM.
It's about the LTFS. Why are we still talking about tape anyway? Is it still a great way to store data, or is it just that's why it's stored in the archive?
It's never going to go away. I mean, interestingly, I was over the fairly large size oil company yesterday, and they've actually moved on to tape. But they still have some tape in there because there's a lot of tapes still licking around that they're going to have to access at some point. Other companies obviously have multiple, in some cases, exabytes of data that they're never ever going to be able to put on the disk, but they're still going to want it in 50 years' time, potentially. So that's always going to stay on tape somewhere. So tape's always going to be around, and it's going to vary, to be honest, from company to company. If you talk to most companies, they probably would prefer that on disk just for the sheer accessibility, but it's just not realistic from a cost point of view, even now. Okay, we're getting to 4 terabyte SATA drives, which is frightening, but they're just about to be released, which lowers the price per terabyte, again, obviously. But at the end of the day, like I said, we are talking about exabytes of data that's stored out there. And although it's an expensive option to keep doing transcription projects, to keep that fresh and up to date, it's always going to be around. And it's still probably the best way of transferring data, I mean physically transferring data. USB drives are increasingly used, but step on one and I'll drop it overboard, and on Monday I dropped one in the coffee and it did work afterwards, but that's probably more luck than judgment. So.
I think that's the thing. I mean, I go on many sites and I see USB disks in cupboards, on shelves. You know, they're great and they're very quick to access data, but people don't manage them. It's just like data. They don't manage the physical bits themselves. With tape, you can off-site it. The index is on the tape. You know, with a USB drive, you have to mount it before you see what's on there. You know, the index is on the tape as well. and it's cheap to put in long-term archive, off-site archive. So I think, yeah, it's, disk is great. I love disk, but tape's going to be around for a while, and there's quite a roadmap for the LTO forward.
Interestingly, I think a few years ago everybody was thinking tape's dead, and the next few years we'll see flash and spinning disk. But what it's starting to look like is that in a few years' time we'll have flash and tape. It's the spinning disk that's now at risk because the price of solid state's coming down and flash storage is becoming more prevalent. A bit slow in this industry maybe, but certainly in other industries, financial services in particular, it's really starting to catch on. So what we're actually seeing is that the middle bit, the spinning disk, it's been squeezed rather than tape disappearing. So it's ironic, I guess.
Well, thank you very much.
Thank you.